Hello students, good morning everyone. Here I am Smita teacher. This is our first lecture in standard 9. Vrushali teacher has covered the chapter number 1 and Sunil sir has completed chapter number 3 and 4. Today we are going to start chapter number 2, polynomials. You have studied concept of algebraic expressions in standard 8. Now let us revise it. Algebraic expression is a combination of constants and variables, that is 2, 3, minus 10, like this, the constants, and variables x, y, m, n, like this. That means a combination of constants and variables connected by the four fundamental mathematical operations plus, minus, multiplication and division is called an algebraic expression. Let us take one example. Now 6x square minus 5xy plus 10y square. Now this is an algebraic expression in two variables x and y. Let us consider another example, that is 5m cube plus 4m minus 10m square. This is an algebraic expression in variable, only one variable, that is m. Now let us see the concept polynomial in one variable. That is polynomial in one variable. It is an algebraic expression involving single variable having only whole number as the exponent are called the polynomial in one variable. A polynomial in one variable x is an algebraic expression of the form p of x. That means the polynomial we are always going to denote it by p of x. Then it is an algebraic in the form an x raised to n plus an minus 1 x raised to n minus 1 plus an minus 2 x raised to n minus 2 plus and so on up to a1 x raised to 1 plus a0 x raised to 0. That means here x raised to 0 means 1. So only a0 we can write here. So this algebraic expression in this form is known as the polynomial in variable x, where this a0, a1, then a2 up to an are the real numbers or coefficients here, and an is not equal to 0. Now, the polynomials in variable x are usually denoted by p of x. That means polynomial we can denote by p of x or f of x or g of x also. Like this we can denote the polynomials. If the polynomial is in variable y, then we can denote that polynomial like this, that is p of y, f of y or g of y. The part of the polynomial separated by plus or minus sign is known as or is called a term. We know that this part of the polynomial separated by plus or minus sign is called a term of the polynomial. Each term of the polynomial has a constant which is known as the coefficient here associated with this variable, and it is known as the coefficient. Now the highest power of the polynomial. Let us consider one polynomial, that is 2x raised to 4 minus 6x cube plus 5x plus 1. Now this is a polynomial in variable x. Now there are how many terms? You know that this is the first term, this is second term, this is third, and this is the fourth term. Now here the variables are in the form of having the exponent. Now here the variable x has the exponent 4. Here x has the exponent 3, that means the power. Here x has the power 1, and here 1 means x raised to 0. So the power of this x is 0. Now this, among these powers, 4 is the highest power. So this polynomial is known as the polynomial of degree 4. That means the highest power of the variable in a polynomial is called the degree of that polynomial. Is called the degree of that polynomial. The highest power of the polynomial is called the degree of the polynomial. Here the coefficient of x raised to 4 is 2, coefficient of x raised to 3 is minus 6, coefficient of x raised to 1, that is x, is 5, and coefficient of x raised to 0 is 1, which is the constant term here. Now let us see the degree of the polynomial in 2 or more variables. For a polynomial in more than one variable, the sum of the powers of the variables in each term is taken up, and the highest sum so obtained is called the degree of the polynomial. Now I have taken the one example here. Now we have to take the sum of the powers of variables in each term. Now in the first term, x and y variables are there, and their powers 2 plus 3 is equal to 5 here. Now here power of x is 1 and power of y is 2 in the second term, and their addition is 3. Here, as it is a constant term, the power of the variable x is 0 here, so it is 0, and here the power of the variable x is 1, so it is 1 only. Now among these, the highest number is 5, so this is a polynomial in variables x and y of degree 5. So degree of this polynomial is 5 here. Now the classification of polynomials. It is done on the two types of basis. First is on the basis of number of terms, and second is on the basis of degree of variable. Now under this, the first type is monomial. Now, a polynomial containing only one term which is non-zero is called monomial. Now, examples are 5x, 7, or minus 1 upon 2x, like this. So, these polynomials contains only one term, so they are known as the monomial. Now, the second type is binomial. A polynomial containing two non-zero terms is called a binomial. A polynomial containing two terms only is called a binomial. So examples are 5 plus 7x, or next is 2m square minus 3, etc. So here in both the polynomials there are two terms. This is the first term and this is the second term, and therefore it is known as the binomial. Now third type is trinomial. A polynomial containing three non-zero terms is called trinomial. Examples are 5x square minus 3x plus 10, or next is 5p raised to 5 minus 6p square plus 4, like this. Now this is also a polynomial in three terms, so it is known as the trinomial. Now let us see the classification on the basis of degree of variable. Now the first type in this is constant polynomial. Now, constant polynomial is a polynomial of degree 0 or a polynomial containing only one constant term is called a constant polynomial. For example, 5 minus 7, 7 upon 4, etc. Now here everywhere there is a or degree of or power of variable x is 0. That means 5 we can write as 5 into x raised to 0. So here power of the variable is 0 and also the degree of this polynomial is 0. Therefore, it is known as the constant polynomial as it contains only the constant term. Now the next type is linear polynomial. Now in this, a polynomial having degree 1. The polynomial having degree 1 is called a linear polynomial. For example, 5x plus 7 is a linear polynomial in variable x, as here the power of variable x in the first term is 1 and the power of variable x in the second term is 0, and therefore the highest power is 1 here, and therefore it is known as the degree 1. This is the polynomial of degree 1 and therefore it is known as the linear polynomial. Now the next type is quadratic polynomial. Now in this example is 2x square plus 3x minus 5. Now here the power of the variable x in the first term is 2, in the second term it is 1 and in the third term it is 0, and therefore in these three among these three powers the highest number is 2 and therefore it is a polynomial having the highest power as 2, so it is its degree, and therefore a polynomial having degree 2 is known as the quadratic polynomial. Now the next type is cubic polynomial. Now example here, that is 7x cubed minus 5x squared plus 9. Now here the variable power of the variable x in the first term is 3, in the second term is 2, in the third term it is x raised to 0, that means the power is 0 here. The term with power 1 is missing, but it is a polynomial in a variable x of degree 3. So a polynomial having degree 3 is known as the cubic polynomial. So it is a cubic polynomial. Now next type of the polynomial is biquadratic polynomial. Now here a polynomial of degree 4 is called biquadratic polynomial. That means example given 5x raised to 4 minus 7x cubed minus 8x squared plus 10x plus 12. This is an example of biquadratic polynomial. Here degree of this polynomial is 4 and therefore it is called as biquadratic polynomial. Now here we can write the linear polynomial in the form ax plus b. That means here this is the first term and this is the second term. Here the degree of the this polynomial is 1 and a is not equal to 0. A is not equal to 0. Why a is not equal to 0? If a is equal to 0, this first term becomes 0 and we will get only b, which is a constant term. Then it becomes a constant polynomial, not a linear polynomial. So here in this form a is not equal to 0. Now, the quadratic polynomial we can write in the standard form as ax square plus bx plus c. Here also a is not equal to 0. Similarly, cubic polynomial we can write in the standard form as x cube plus bx square plus cx plus d. That means it is a polynomial having 4 terms and with degree 3 here. Here also a is not equal to 0. Then pi quadratic polynomial, the standard form is ax raised to 4. As it is a biquadratic polynomial, it contains it having degree 4. So a into x raised to 4 plus bx cube plus cx square plus dx plus e. It is the standard form of the biquadratic polynomial where a is not equal to 0. Because if a is equal to 0, then it becomes a cubic polynomial, not remains as a biquadratic polynomial. So a is not equal to 0.